Hello and welcome to week 3, day 11 of the summer 2025 database driven web development course. So today's going to really be all about MongoDB. Just getting it all set up and learning some of the basics of it. First, I kind of wanted to discuss. I had a little bit of concerns about the first lab. Well, actually, that wasn't the first lab, second lab, but first lab where we were really, using Express, and there's a lot more to this. You had to, understand the basics of Express and be able to use Postman to test your routes. Plus, we're deploying to Google Cloud, so I know there was a lot involved in all that, and I've just kind of hope that some of the students seem to have struggled, either just didn't get it completed or whatever. But just wanted to please give me some feedback, all the students, especially ones who are not able to come to the live lectures. If you feel like you're struggling in the area, or was it just kind of a time commitment thing, you weren't able to commit the time to really do what you needed to do. So please shout out to me, either on Discord or an email on how you felt about the lab, and if you think that there's some areas of that we need to kind of go over again, or if it was just more of a time issue. So all right. So this week also is our first hands-on test. And for this course, like I mentioned a while back ago, for the hands-on test, we're just going to have them do on Sunday. I kind of like to weave some of them in during the week, but I don't want to do it one way one week and a different way a different week. And some of those hands-on tests just takes a little bit of work, and and I know that there's some students that work full time in that, and I was very happy with in the web technologies course. A lot of students were able to get those hands-on tests done. My only concern is sometimes when we make that transition just to have everything due on Sunday, it's just easy to procrastinate and start everything later in the week, and that's my biggest concern with doing that. But as of right now, we're just going to leave the hands-on tests for the most part, and I'll give a big shout out if for some reason it's going to be less than that. But generally, at this point, all assignments are always going to be due on Sunday by midnight. Did want to go over real quick here. I did do a video on a hands-on test, and I really didn't go over much. I realized that, but I'm going to just point out a few things here again, just to reiterate. The important thing is, make sure you checking your code in the right place, commit your code in the right place, but, be careful to follow these directions. If it asks you to do something, do it like it asked you to do it, right? So here you got dependencies. So you've got 3 different ones. These all need to be there, right? You have to use debug, use .env, and use express. Now, if you see .env, you got an environment variable, right? You're using a .env file, right? Then obviously this is a lab that is pretty much using the very first lab we did, and we're just making it into an API. Real quick here, so to receive full credit, make sure you follow the coding standards below. And like it's, still, take a quick look at that hands-on test video I did. I know there's not a lot there, but the thing I'm just wanting to point out is really just follow the directions. That's really the only thing I'm really trying to get through here. So all routes must use the exact specified path, so it needs to be a post. It needs to be written like this, right? Make sure that you're putting on the right port. So this is a port that you can use your .env file and put this 5010 in there, right? And right here, like all in your request body variables, names must match the names exactly like here. Right? So when I test one student's work using Postman, okay, and I'm going to have all these variables in there, I can bring up the next student and do the same thing all the way through. And that's not just to make it, well, obviously it does make it easier for me to grade and everything for the instructors, but, it is just important to follow directions because that's kind of part of what happens as far as requirements in the real world. There's going to be some specific requirements. You've got to follow those requirements. You just don't get out there and kind of do whatever you want to do. But, some things, yeah, there's more leeway, obviously. But, it's very important because if we have to keep on changing the variables, take me forever to grade all the homework assignments, right? So please make sure you create those variables with the right names. And I guess that's all I'm really going to point out here. Like I said, you can look at the video. And if for some reason you did something wrong in your other lab, you want to make sure you correct that here in this lab. If you did something wrong as far as, maybe like the income, a couple people did the income tax stuff a little bit incorrectly. So make sure you correct how you calculated the income tax. So fix that in this one. Okay, that's all I'm really going to go through. You can look at the video on that. All right, let's get back to our list just to make sure that so basically here today, we're going to just kind of start getting accustomed to MongoDB. We're going to register an account. We're going to create a cluster. We're going to download and install some things. Both Compass will be an executable or run on your computer. And we're also going to download a zip file, which is going to be the Mongo shell that you'll just be able to bring up in your command prompt once we get configured to do that. And then we're going to go ahead and go through some Mongo database theory and concepts. What is Mongo database? How's it different than relational databases? Things like that. And then we're going to go ahead and spend some time learning, some of the commands in MongoDB. Actually, the commands that we're going to use in the shell, which is called mongosh. That's the shell. It's basically Mongo with SH on the end for SH for shell. It's Mongo with SH for shell. So, okay, so let's get started on that. I guess I can just kind of close that out. So what we're going to do here is we're going to kind of just go here and install the software, and we're going to come back and talk about what it is later. So I've already got an account in that, but I think I'm going to just go ahead and create a new one. So kind of to start out, and so have a couple students with me live online. So first, if you kind of go to the Mongo main page, and I'll just drop that in the chat. Go to that, and when you get there, go ahead and click Get Started. And then here's your Mongo sign up. I would go ahead, use your, I wouldn't sign up with Google. Not that you can't, but I would just go ahead and just do a regular sign up here. Which database? Let me see what email I really want to use here. And some of this is this company that's, it's optional. Obviously, an email, you need to have your email address. Now, when you create your password here, when you create this password, you could suggest a strong password, do that, right? That's one option for you. Or you can create your own, okay? The important thing is make sure that when you create your password, because it's going to be used in a couple different places, so it's important to hold on to this password. So write down, when you're doing this, write down your email address, whatever email address you use, and whatever password you create. Okay. So let's see what I'm going to do here. Let me try this again. All right. Actually, I'm going to grab that off here for a minute just to make sure. All right. I'm going to agree to terms and service. You want to go ahead and create your Atlas account. And sure, I'll save it. That's one way to do it. I don't know if you guys use the little thing within Google. I do. That's very handy. Great. Now verify your email. So open up your email account. And then on that is just a verify email. You'll receive an email. Just be verify email link. Just go ahead and click on that little green button, and then go ahead and hit continue. Okay, welcome. What's your primary goal? Learn MongoDB. How long have you been developing Mongo? So whatever, you can choose this, doesn't matter. What programming language? They just want some information here. JavaScript node. What type of projects? What else do they have here? Oh, let's just do other. All right. No, let's not do other. Let's just do that. And then we'll say, will your application include any of the following architectural models? Probably won't do much in there. For here, I don't know. You can just do that. Like I said, it really doesn't matter. Okay, after you've registered, you should end up at the dashboard of Atlas. If not, open up Atlas, which is cloud.mongodb.com, right? You probably should save this, kind of like here. I went ahead and just drug mine to my bookmark. However you want to do it. But it's probably a good idea to either get a shortcut for Atlas or bookmark it so that you can get to it quickly, especially until we get done with this course, right? So you come in here, you should have create clusters here. If you come in here and you're at a different spot or something for some reason, this is going to be overview. It's going to have build a cluster. So here's create a cluster. So go ahead and click create. And I'm going to discard this just because I was doing something earlier. So I'm going to discard that. So this is what you should see when you come in. It's going to basically say deploy your cluster. So you got different options here. Obviously, we want the free option. So make sure you click on free. If not, they're going to ask you for some charge card information. There is limit to what you can do, so don't get crazy. Up to 512 megabytes of storage. So obviously, if you get past that, that's where these others got 5 gigabyte, 10 gigabytes of storage. It's on a shared RAM, meaning it's shared. You could be shared with multiple different instances of your cluster, right? Sometimes companies don't want to do that, for development purposes and for what we're doing. Shared's fine. So then come on down here, and you should just kind of, I guess, for the most part, it'll probably be defaulted like this, but it might not be. So Configurations, just whatever. Cluster 0 is what this is defaulted to, and that's fine. Choose AWS if it isn't already selected. And if the region's not selected, select North Virginia. North Virginia, in North America, North Virginia East 1. It has a limited amount of ones to select from. So for this free one, so they've got it limited. So it's not like you can choose Central or anything. So US East 1 would be North Virginia's. So you got that. Everything else you can just go ahead and leave as default. All right. Make sure you got free AWS North Virginia and then click Create Deployment. And so here for now, you can go ahead and not worry about this, because what we're going to go ahead and do is we want to make sure we install Compass and the shell. That this is going to be our primary ways we're going to access things is through Compass and shell. Except we're going to also be accessing it through our application as well, right? But so for now, you can just go ahead and close this, okay? So just real quick, we can click on our clusters here, and we're going to see our cluster. It's loading it. Cluster is ready to use. It's loading a sample data set, okay? It's loading a sample data set. But you can go ahead and just let this do what it's doing. And while that's happening, we can go ahead and download, install the shell, and also the Compass software. So go ahead and go to the link. Here, we can just kind of do this probably. Mongo Compass download. And so if we go to this moncocom.try, this one here, you can go ahead and download two different things here. Download MongoDB Compass download. And this is actually a application that will be installed on your computer. So just go ahead and click the download for that. Obviously, make sure that this is correct for you. It's going to default to this based on your system. And then also up here was the shell. So you also want this DB shell. So you want to download this as well. I already did it, so I'm not going to do it again. But go ahead and download that. Okay. And so this one's going to actually download a zip file. Okay. So here I went ahead and double click on Compass here. It's being installed. Okay. I already had this, so it probably just overwrote that version. So I already have things. You might see different things than what I have here. Okay. So you have that. Okay. And then we'll also go ahead and here, what you want to do here is this is a zip file. You go ahead and, it depends on your system, Windows version, whatever, but you want to extract the zip file. So however you've done that in the past. So here I'm just going to extract that. And I already have the latest, so I'm not going to do it again. And I put mine under, I just have a dev tools folder. And I went ahead and extracted it here. Okay. So you extract it wherever you want. Okay. And then after you complete that, so you might want to pause this until you complete that. And then let's go ahead and go to wherever you extracted that. So that was still my downloads folder. So wherever you extracted that. So I'm going to go on mine. I have a tools here, and this is where I extracted it. And then in here, what we want to go ahead and do is open up the bin directory. And as you can see, this is an exe file application, all right? And if you don't see that exe, you don't need to. Just kind of wanting to show you here, options. Oh, wrong thing. View. Show. You might want to do, if you don't have file name extensions, just so you know what it is. If you don't have that checked, you might want to check that. Just easier to see that. So, it's an application, right? So, but what we're going to want to do is we need to, from our command prompt, from our Windows command prompt, we want to be able to access that without having, otherwise we'd have to go to this directory to run this. We don't really want to do that. We want to run it from wherever we're at in any directory within the command prompt. So what we'll go ahead and do is go up here and click in that window up here and just copy this. All right, click up there and copy that. And then we want to go ahead and go to environment variables. Under environment variables, so you can go to, let's see if this isn't gonna, okay, you can go here, and I don't know how it is on your system. It could be a little different. I want to edit the system environment variables. You might have to play around to get to this. I'm sure that you've done this at some point in time or another. And here in system properties, you got environment variables. I'm going to click this. And I'm going to go ahead and put this not at the user state, but I'm going to put this at the system level. So you click on path. Obviously, if for some reason you're not the administrator on your computer, you might have a problem changing that. You can add it to path for yours if it's just for your own specific user. I'm going to add it to my whole system. So I'm going to highlight path here. I'm going to click edit. And I've already done this before, but I'll just, because I'm already have this in here. Let's see where it's at. Oh, yeah. So I have it in here, the last one. So if you don't have it in here, just let me delete this and act like it's not there. Okay. Here, let me go back to that. So if I come back in here, now it's not there. So you just want to click new up here and you want to copy that in here. So that's going to be the path to that bin folder. And within that bin folder is that Mongo, that exe file, right? And then do that and just hit OK. All right, hit OK. You can get out of there as well. And now go ahead and make sure that you have all your command prompts closed. Close them if you have anything open. And then go ahead and click this. And then if you type in mongosh, M-O-N-G-O-S-H, which is basically, right, mongosh. So you'll see the server generate these startups. Yeah, it actually did connect, didn't it? That's interesting. Yours might look a little bit different than this, okay? And that's fine. That's fine. To exit this, but the important thing is that you got something here. Current mongosh right here. I think I already have mine running, so it kind of connected, but it may not always be the case. The important thing is that you get something back. If you run mongosh and it comes back with command not found in that, then that's where it needs to make sure you have that in the system's environment variables, right? So here I'm just going to go ahead and hit a Control C just to get out of that, okay? And I'm going to show you how to actually connect to that as well. So we're going to come back here to our clusters. And we have, this is all set up now, right? So I'm going to come back here. I'm going to click on, so the next thing I want to mention before we go any further is for your cluster, it's going to set up access just for you to use depending on your IP address. And the way Mongo configures things, it doesn't allow access from like anywhere. And so let's just say you set things up on your home. Let's say you got a laptop, computer, whatever. You set things up at home. And then let's just say you went to a relative's house for a barbecue, and then you wanted to do your homework while you're hanging out there. And so then you went ahead and tried to access it. You can have some access issues, okay? Because you're going to have to add the IP address, okay? So if you come back down here to network access, it'll show you different IP addresses. And what you want to go ahead and do here is, mine is here. Let me just delete this as if it wasn't here. So it's just going to give you your current one. What you're going to want to do here is you're going to add your IP address. And what's really best, so that you can get access from anywhere, is click Allow Access from Anywhere. And then also when I'm grading your homework, I can access this as well. If you don't do something like this, I'm not going to be able to access this to grade your homework when that time comes. Okay, so go ahead and just click allow access from anywhere. Okay, and it's going to put this kind of a entry in there and hit confirm, and it will go ahead and add that to yours. Okay, so now you have that. It's pending. It'll take a little bit. Let's see. Database access. This is just your user, so you're the only user that can access this. Okay, and then your thing here is active, so this means you can access it from anywhere. So that's probably what's best. Even though for some reason somebody makes it easier for someone to hack into your environment, which probably is not likely to happen. Anything's possible. But if you do, then you can just go ahead and create a new one. Worst case scenario. Obviously, you actually want to go ahead and do the multi-factor authorization stuff. That's always an important thing to do as well. Okay, so now we have that. Also wanted to show you. So basically coming to like the main page all the time. So I'm just gonna want to show you to make sure you're always gonna, this is basically the main page. This is where you're always gonna come. So to connect to your cluster here, what you're gonna want to do here is click this connect button, and you have two different options here. If you already downloaded Compass and you already have the shell, so I'm just gonna choose the shell here, okay? And then it says, I have Mongo shell already installed. You want to click that. And what you want to do here on this is you want to go ahead and copy this. Okay. You want to copy this and you want to paste this right into here like that and hit enter. And then it's going to prompt you. This is your Mongo cluster. Right here, it starts your Mongo cluster. There's your username. You want to hit enter key. And then it asks you to enter a password, okay? And so what you're going to want to do here is the password that you created when you did your cluster. So you got two different logins, right? You had your email address and you created a password to access MongoDB and Atlas, right? To log into Atlas and just the MongoDB registration, all that was one set. Then you had another password, another username and password, and that is for the cluster. Okay, so you need to keep them separate. You need to make sure that you have them written down, or you're gonna have to reset them in that. Okay, so make sure that you have both of those logins somewhere, so easy access to that. And so here, like I said, I had the shell script. So let me go grab my password. So I did the password where it went ahead and created a password itself. Let me grab that here. And so here I want to enter the password. I just right click and it's going to paste it in there. Hit enter. And it's going to take a second or two. Sometimes it's slower than other times. And if you get back this line, you know you have access. Okay. And just one quick command here is show DBs, and this will show you your databases. And it's just going to have these by default, and it has this sample mflix, and this is the one you're going to be using for your lab assignment. Okay. But there's others as well, other sample databases. So that's about all you really need for right now. The important thing is to make sure your cluster's running. Make sure you can get to your cluster. You can log in. You can get to the shell because we're going to do a bunch of commands in here. And if you get into this point, we should be good. Okay. It has Angular. So Angular is another very popular front-end framework, and it's used more for enterprise-type applications, and it's a little more difficult than React. But obviously if you learn React, Angular is going to be a little more easier for you because you kind of already used to the other pieces of the stack, so it kind of helps a little bit as well. And some of the concepts are the same, but Angular is a little harder. So if you ever hear Angular, you can kind of always remember, because you're going to see, especially start looking for jobs and stuff like that, you'll see Angular in different places. And maybe that's something in the future you want to kind of spend maybe a little time learning a little bit about yourself at some point. But I'm sure that you guys have lots of other things to do. But it is an option there within a stack. And a lot of times too, even though speaking of jobs, just because there's some certain technology that's mentioned in a job doesn't necessarily mean that you have to know all those things. Many of those job descriptions, everything that's listed in there, it's hard for almost anybody, because every company uses their own set of technologies. They might have a MERN stack here, but then there might be talking about some other stuff. You might say, oh, well, I know this, but I don't know this other stuff. You can't really think like that, because, really technology is all about, especially in this field, it's all about really having the basic technical skills, and then having the willingness and drive to actually learn new things. And if you have both of those, you can go very far with that. Okay. But back to this, so LAMP is a very popular one as well, and it's stands for Linux. Linux is a different operating system than Windows. Now MERN, these other stacks don't mean they have to run on a Windows environment. They can run on different ones as well. But the LAMP stack is a Linux Apache, which is I don't know if you recall, we kind of talked about this a long time ago in web technologies. Apache is basically a web server. So Linux, Apache, MySQL, PHP, Python, or Perl. So the P stands for, one or more of those. Okay. These are all different languages: PHP, Python, Perl. PHP was very, very popular early on. I mean, still is, but early times of the internet, everybody was just using PHP to create web pages, for dynamic web pages, right? Once you get past HTML, you want to do something dynamic, you use PHP. But there's many different options now available. And then one thing to notice is a lot of these databases that are here, you've got MySQL. All right, these are both Mongo. This one here is Mongo. This one here is Mongo. This is another MySQL, and this is PostgreSQL. Out of all of these databases listed here, okay, Mongo's really the only one that's not a relational database, and we'll talk about that a little bit more here in a minute. Here's just some other various ones as well. Ruby on Rails, and you don't really need to know all these. Just kind of, it's beneficial to know that they exist. You might see them in job listings, right? ASP.NET. Basically the two stacks you're learning as part of this program is going to be the MERN stack, and then the ASP.NET stack. So this is the C#. Most of the students in here haven't taken the second year course yet, the ASP.NET course, but you have completed C# one. So the next one will be the ASP.NET. So you'll be rounding this off. You'll understand this stack by the end of next semester, right? Because you'll be taking that other course there, and they're doing actually that course has really changed here in recent times. So you're going to be doing some really cool things in there, and obviously at the beginning of the class for that. The instructor, you'll have Mr. Gudmanstead, and he's going to go over all the basic C# stuff again before you dive into newer stuff. So no worries on that. And this is one that, I don't know. This is called the Java EE. Yeah, okay. So this is the kind of the stack that I've worked on. Most of my career I was a Java developer. I don't necessarily agree with all this, but most of the time Oracle was a database. There's other databases as well. Um, um, this could be almost any database here, but yes, Java and their Java Enterprise Edition that has some additional functionality than just the basic Java language. Java EE is kind of like Java. These are like add-ons, so you can do a lot of more complex things. These databases here, yeah, I mean, you could use any of these plus many more. Um, I don't know if this is really part of the stack. DB2, I've used DB2, but Oracle's very, very popular. Um, okay, did want to just show you a couple things here. So here we go. This is some recent data. I don't know how reliable this is. Just kind of shows you popularity rankings of different database management systems, with Oracle being the most popular, then MySQL. The Microsoft SQL, Postgres, the MongoDB being number 5 here. One thing that's kind of interesting to notice is you kind of look at the model here, relational databases. Mongo is not a relational database, it's a document database. So really almost all of these, all the way down to here, Redis is a special kind one. It's a key value type thing. But a lot of these are just relational databases. The most popular ones, Mongo's the one that's not a relational database, it's a document database, right? So it's kind of a different database model there. Might as well mention this now. So then also, as far as MongoDB has their own, like a lot of technologies, they have their own YouTube channel. So there's a MongoDB YouTube channel. And obviously they have a intro to MongoDB. This is just the home page of the channel, I should say, the channel page of the MongoDB. And so they have intro to MongoDB, so you can go through all, if you want to kind of really up your skills in this area, you can go through some of these different videos, but it has an intro to MongoDB. They have a lot of more advanced topics as well. Playlist here, they have different playlists depending on what you're doing. But they do have one that's an intro that would be a good place to start if you're interested. Okay. All right, let's close that out. All right. So in the relational world, relational database, very popular. They started, many, many years ago, decades and decades ago. Relational databases were kind of the first databases around, and they're all about tables, right? You've got columns, row, everything's columns and rows, and then you have ways you can have multiple tables, and you have ways to associate one table to another table to another table. Okay. Nowadays, there's a different variety of databases nowadays. Like we have document database, there's key value pair databases. There's different databases for different reasons. But the whole relational database is still the most common, and you especially go to any large organization, they're still going to be using relational databases. They may have moved some certain things within their organization to, especially, organizations been around for a long time, right? I should say that too. Large organizations has been around a long time. They're very, very likely to have relational databases. And, it's, just because other databases, other options come along, they're not going to just change. And they've got they've got a lot invested in relational databases, right? So relational databases, and especially in enterprise, are very, very popular and still used. Now, so that's, storing data is all about, for relational databases, is having, basically it's all about rows and columns and tables, right? And you can associate one table to another table, use what's kind of called a foreign key. So your your primary key in one table is a foreign key in another table. It's a way to associate. It's a way to associate one table to another table. So here we're just going to go ahead and talk about a JSON object, which is a JavaScript object notation. And this is a basic, well, this is actually showing, yeah. So this is basically a JSON object. Now JSON is a little bit different than, there's some things that are a little bit different than a regular JSON object. And then what you use in what's MongoDB. But this is showing you a basic JSON object. You know, you have basically named values, and the name's always going to be in double quotes, right? And then you have values here, okay, different values. Here, whenever, so you're always going to have obviously an open curly brace and end curly brace. And so this is considered a document. This is the ID of the document. Okay, this is the ID of the document, and here's some properties of this document. Here, whenever you see a bracket, open bracket, this is going to be an array. So here you've got an array of items, and this is a product array where you have multiple products, and you have a product ID, right? Name, price, quantity, etc. So this is an array. Within this document object, within this JSON file, right? Let's see, order 2 is a JSON object, okay. I think it later talks about BSON. It's basically, BSON is basically replace a J with a B, and BSON was created. BSON was created really just for MongoDB database, and so we'll talk about this more in the future. But it's more about taking JSON and it's making some change, a little bit of changes to JSON, so that you can do things with MongoDB, and it was designed just really for MongoDB. But we'll talk about that here in a few. So first, so what is MongoDB? MongoDB is considered a NoSQL database. Okay. Now, an SQL database, when we're saying an SQL database, we're basically talking about a relational database, right? An SQL database is like a Windows SQL Server, MySQL, right? And those other ones we were looking at, Oracle, and there's IBM has DB2, there's, Postgres. All of these are SQL databases, relational databases, right? So the whole idea of NoSQL was really kind of maybe a very confusing thing that they probably should have done, because, some say that NoSQL stands for, some say it stands for not relational, okay? While others say it's not only SQL. So a lot of confusion on, what does that really mean, NoSQL? And so really basically, probably the best way to really look at it is it's basically, either way, most agree that NoSQL databases are databases that store in a format other than relational tables, right? So you don't have columns and rows in tables in a NoSQL database, okay? And so MongoDB is not the only NoSQL database, right? It's a document database, and it's not the only one that's around as well, but it's the most popular one, okay? It's one of the most popular ones. Now, also on the different cloud providers, sometimes, they have databases that, see, like we can sit there and use MySQL locally and things like that. Some of the cloud providers, you're using their databases within the cloud environment. Even though we do this cluster, we actually do have on AWS. But, Mongo, you can actually download Mongo to run separately. You can deploy it separately. It doesn't have to be in the cloud. You can have Mongo, installed locally on your machine. So it can be done used in different ways. Okay. Some of these cloud ones, you basically have to use it within the cloud environment. So all these different providers, and it's obviously important to know the different cloud the top 3 cloud providers, not that they're the only ones. It's basically Amazon, AWS, which is Amazon Web Services, right? AWS, Amazon Web Service. you got Microsoft Azure, and then you have Google Cloud Platform. Okay. Now, obviously there's a lot involved in cloud platforms, and it's as far as learning them, it takes some time, and I understand it can be overwhelming. There's a lot of different tools, a lot of different platforms, and that, and it's you just kind of have to accept that in the way things are in technology nowadays. But like I said, basically from a database thing, MongoDB could be installed locally, or it could be in a cloud type environment as well. Let's see, what is NoSQL? So can store relational data. Yeah, they just store it differently. So you can still associate documents. You can have different collections, and you can have different collections within MongoDB. You can have documents that relate to other documents, and we'll look at that as well. Okay. But in fact, when compared with SQL databases, many find modeling relationship data in a NoSQL database to be easier than SQL database, because related data doesn't have to be split between tables. Okay. You can actually kind of combine things together, and we'll look at that. So yeah, NoSQL data models allow related data to be nested within a single data structure. So NoSQL databases emerged in the late 2000s as the cost of storage dramatically decreased. So yeah. So yeah, over time, the cost of storing things, a long time ago, just to have a hard drive on your computer, they were very expensive, just because just the technology was very expensive. And as time's gone on, we've been able to get bigger and bigger hard drives. The same thing, with your computers is, these databases run on servers somewhere, right? Well, obviously, I say you could deploy something locally to your own PC, right? You can, but a lot of databases you're going to use generally are going to be deployed to some server somewhere, or being like hardware, kind of that looks like a computer, right? That we've talked about that in the past, but it could be deployed there, or it could be deployed. And a lot of times the companies have their own in-house type servers as well. And then they have external stuff, and a lot of them are using cloud as well, right? So there's kind of a hybrid thing where they're doing both, right? Sometimes they'll have internal type servers, and sometimes they'll have cloud stuff, right? But the storage on all of those is a lot cheaper nowadays. Okay. Yeah, so here's the cost of megabyte data over time. So the cost to store data has dramatically been reduced as time gone on here. Look at, here we've got the 60s and the 70s, 60s, 70s, 80s. You got to a little bit past, started getting into the 90s, started going down, then it really shot down from there. So NoSQL unstructured data. As storage costs rapidly decreased, the amount of data applications needed to store the query increased. This data came in all shapes and sizes: structured data, semi-structured data. So when structured data is like, your they have some association, products. This product has an ID, it has this property, but some stuff that's unstructured, some other things is just a video. Boom, storing a video, it's just a video. It's a blob of data. It's a big thing of data, right? It's not structured. It's not, data like you normally think, right? Files, images, things like that. They're different kinds of data, right? It's still considered data. A file is considered data. A video is considered data, but they're different. They don't have associations with data like products and things like that, right? NoSQL databases allow developers to store huge amounts of unstructured data giving them a lot of flexibility. Do want to go through this a little bit. So as far as agile methodology, and this would be beneficial for you to really, I really suggest, before you're out looking for a job, understand what agile methodology is a little bit. Okay, so originally when projects were created years ago, and still to this day, the way a project was done is there was usually like a business owner, and this business owner wasn't necessarily an owner of a business, but when I talk about business owner, I'm talking about like someone's responsible for something. Okay, and let's just say from an internal organization, let's just say you work in the technology department and there's a finance department. Well, maybe maybe the manager from the finance department wants a new application that they can't find something similar, and they want something built that's customized. So this may be something that they request that the technology department would create for them. Because they can't find some off the shelf, some software that already exists that does what they want to do. So, they work through the organization, obviously got approvals and everything. Well, somebody's going to be assigned to be the business owner of that, right? The business owner could, just an employee within the organization, usually somebody in some management capacity, someone who's responsible for that project on that side, right? And then you're going to have somebody who's responsible for that project on the technology side as well, okay? So kind of, even though it's within the own organization, you got a project manager on the technology side, and then you got I'm saying a business owner that's on maybe like I'm saying the finance department, right? So what happens is, they're going to work together. The technology department, usually somebody business analyst and project manager, and some other functions as well, are going to work together with the business side, right? The finance department, to work out requirements for this new app they want to build, right? So back in the day, and then like I said, it still happens today. There's an idea of a waterfall where you're going to come up, well, what do we want this thing to do? Well, we create all these requirements of what we want this application to do. And everybody signs off and says, yes, this is what we want. Usually it takes a long time to get through all of that. And then once they do, and it goes into a different part of the cycle, a different stage of the cycle where you're going to eventually start working on that and developing that, right? But all the requirements have already been built out. And this is how things were done many, this was almost how all projects really were done. But things have changed within time and for many different reasons. And if for no other reasons, a lot of times the business owners or the people who are wanting things, they might want some things they want, but they don't know anything. So another way to do this instead of the waterfall, where you do everything, is you follow more of an agile methodology, where you kind of you come up with some things you want to do, you create that, and you just kind of keep on iterating over that, because people change their mind. The bad thing about having a project where you have to flush out all the requirements before you start, people by the time things get built, people start looking at it and saying, well, that's not what we meant, or we thought that, but now, somebody else was saying that, but now we don't really think we want that, right? So Agile became a much more useful methodology where you can kind of build some things and then you keep iterating all over that, okay? We know we want this, a few things we don't know about. And then, you might put in, okay, well, let's try this, and now let's change that. And then you keep iterating until you get to a final product. So there's a lot of benefits. Usually that final product is going to be a much more better product than the one that you created all the requirements, and then by the time it gets done, maybe it's not as useful as you wish it was, right? So it's just a different methodology. And it kind of helps, too, with the NoSQL databases that you can actually save things in a much more dynamic way. If you did the relational databases, like with all the requirements, you're going to build out this whole database system based on these requirements. And then when you get farther along, you get towards the end of this project being completed and start looking at this, and people start saying, well, it's not what we wanted. Well, you already got this whole big database structure. You got this whole model, you've got this all built out. Whereas something like a NoSQL database, it's much more flexible. You can do some things and say, oh, no, we want to do some things different. It's a lot easier to change. It's much more dynamic. Okay. So relational databases were designed for a world where hardware was expensive, both storage and memory. Software engineers were much cheaper than the hardware. Hardware used to cost a lot of money. I remember spending. I'm going to date myself here, but back in the late '90s, I remember spending like $2,500 for a laptop back then. Not that you can't spend that and more now, but you got to figure the cost of everything else. I mean, the salaries were a lot lower then. $2,500 back then was a lot of money, and people spent a lot more than that. I remember spending about $2,500 on a laptop back then. I think it was actually closer to about $3,000, and you can get a lot of laptops for a lot cheaper than that nowadays, right? And that was I'm talking about late '90s, so I'm talking about almost basically over 30 years ago, right? Over 30 years ago. Software engineers were much cheaper than the hardware. Software engineers were seasoned employees of the company. Systems needed to handle less than. All right, it's just talking about less concurrent users. NoSQL is really good for lots of concurrent users. The internet did not exist yet. Okay, yeah, well, they're talking about even before the internet. But like when I was talking late '90s, that was early days, very very early days. But a few years before that, you're still going to spend a lot of money, for hardware. Hard drives could only perform sequential reads and writes. Yeah. Business requirements were well known, mostly static. So basically, what I was just saying earlier, well known and mostly static, is basically that's the whole waterfall methodology where you create all these requirements, you sign off on these, and so you've done all your work up front, and then you start building your product, right? And some of these projects take a long time. Some of the people who are actually working on, like I was talking about the example where you got a finance department wants a new application, and some of those people in the finance department not even be there anymore, right? By the time this process even takes place, right? Because it can take anything substantial, it could take quite a long time, right? And another thing too is I do want to point out, before waterfall and more of an agile methodology. Sometimes you get to a point where you say, we don't really think we need that anymore, and you're better off being an agile thing where you can kind of do it slowly and kind of keep iterating than the whole idea of building all everything at once. And then I don't know, it's easier to make a lot more decisions along the path, right, during the life cycle of building an application when you're using it like an agile methodology. Databases today, just say it needs to, handle lots of concurrent users, lots of records. Hardware is cheap. Everything's cheaper. So another thing is business requirements are not well defined and understood, right? Business requirements are constantly changing. Yes. And that's the whole idea of what I was referring to more from the waterfall perspective and the agile. And just to, I was using an example of like a finance department. That would be an internal application, right? So sometimes that's the case, but sometimes you're working in an organization where you're building for an external client, right? You could be building from some other company or maybe other, organizations like, there's a lot of government contractors, right? There's firms that build stuff for the government, right? And the same thing there is, you still got a business owner. It's all that, right? And it's kind of the same concept, right? But it's just an external customer instead of internal customer, okay? But I think it's kind of important to understand that that's kind of how it works. Sometimes you could have internal customer. You're building something for an internal customer within your own organization. Sometimes you're building something from an external customer. It all, kind of all depends, right? Depends on the company, what's their model, what they're doing, right? And it really a lot of things when you build for an external company, it's made a lot harder in some ways because you don't internal people know each other and stuff like that. Well, in external, you don't know the level of expertise, you don't know a lot of other things, and a lot of customers really don't know what they want. They might say, well, we know we need to build this, but they don't really know what they want, and getting everybody on board. So it's a lot more challenging, especially from a waterfall standpoint where you try to flush out all these requirements, right? That's where Agile really comes into play. So you can build some little things and just go from there. Auto increment, yeah. All right, I'm not gonna go with that. Okay, well, just kind of point out, and you should know this at least a little bit by now. Like you got primary keys and foreign keys. I'm not gonna go through all of that. Tables do not allow for nested documents and arrays. Yeah. So we kind of looked at that format at the beginning there, that JSON object where you've got we had an array there, right? So you can have you can have a document that has an internal document, a document of documents, and then you can have arrays in the middle and stuff like that, right? So there's a lot of flexibility that you could do. All right. Let's talk about object relational mappers, ORMs. So ORMs are frameworks where you provide a layer between the database and your code. ORMs map methods and objects onto database data and operations. It's kind of like it's kind of look at it as a middleman between your code, your code and the database. ORMs are great because they provide some special methods and stuff that you can just call some methods and that without having to know all of the specifics of the database, right? You don't have to know all of the specifics, and you can just call some certain methods, right? And what that's called is the concept of abstraction. So it's very very important, especially in object-oriented programming and that abstraction, whereas you're kind of hiding the lower level details, right? You're just providing a higher level. You're providing a higher level access, like I'm saying, methods and that. So you're providing without having to know the lower details of the database, right? So not everybody who codes actually knows all. They may not have all those database skills, right? May not have all those database skills. So having an ORM, you just say, I want to save this, right? You call this method save. You call this method delete. You call update, right? So you have these kinds of you kind of have this middleman, so to speak, and the idea abstracts away that the specific database stuff, right? Because sometimes you could actually, in some cases, you could actually replace one database with another database. That's possible to do when you're using certain, and it depends on what kind of tools you're using. But there's some some object relational mappers that sit between your code and a database, and some of them work with different databases, right? So however obscure the problem, okay, let me see, hide a lot of performance problems, prevent many optimizations, yeah. In theory, they make it easier to migrate to different database management systems, but migrating to a different ORM is much harder, yes. Okay, some databases have attempted to overcome this by adding JSON data types. All right. So this is really isn't my opinion. This is another instructor's opinion, but yeah, I agree. Relational databases cannot handle more than and I wouldn't necessarily say this is written in stone, but it takes a lot more. It takes a lot more. It's a lot more cost. There's more cost associated. It takes a lot more expertise and configuration to handle lots of concurrent users. Okay, some of these NoSQL databases are kind of set up for many concurrent users. Relational databases are not optimized for distributed database servers. Relational databases are not optimized for unstructured and nested data. Okay, let's see here. Okay, so here's some different terminology. So both a relational database and a non-relational database have schemas, right? They'll both have schemas. Now a relational database will have tables, right? It's all about tables in a relational database, all about rows and columns and having fields and cells, right? Having fields. So that's the name you're giving it, right? And cells pretty much your data, right? The cell's your data, right? Now, for non-relational database, you have collections, okay? You can have multiple collections. So for like the final project, you can have a user collection, a bug collection, right? You may have some other collections as well, right? So basically, a Mongo database is made up of collections. Okay, so it's made up of collections, and collections are made up of many documents. Okay, and in these documents you have fields and you have properties. Okay, each field will have a key and a property will have a value. Okay. Schema. So this is just showing a MySQL database, which is one of the relational database. Schema must be strictly defined at the beginning. Schema, for MongoDB, you can have a database or you don't have to have, or schema, you can have one or you don't have to necessarily have one. Okay. The benefits of having one is one of the concerns sometimes, I should say, with MongoDB is you can pretty much save anything in there. So, and you'll find that out when we start doing things for this final project, especially. So, you can pretty much save anything, but if you're expecting certain things to be there in your code that are not in that document, because you could change that document around to be different, and if it doesn't match, then it's not going to quite work like you want it to. So that's one of the downsides. Even though MongoDB is very flexible and you can pretty much save any document you want. But if you really want it to, if you really want things to work and to follow some pattern, then you need to define that, right? So schema should account for future growth over the next 10, 20 years. Okay, it's just talking about schema. Schema is difficult and slow to change. All rows in a table must have exact same columns and data types. Yes. Application breaks if the schema is not exactly as expected. Yes. Collections of fields are added when needed. So you can just add things whenever you want. Documents in a collection can have different fields or data types. So you can create a document, and you may not know, you're just doing a base document. You might have a few different fields in there, and then you come along later, it's So and then you're creating other documents. You'll have to go in there and edit the original stuff to make it match, right? However you want it to look. But you can just add a new field very quickly, right? You can then add a new field to a document, right? And once you get good at things, you can do command line stuff and add fields to your documents, or we can use the tools as well that we have, the GUI tools as well. But so that's an option there. Okay, documents in a collection could have different field and data types. Applications can easily handle changes to the schema and data which doesn't conform to the current schema. All right. We don't have much more here to go, so we'll be there quickly. So MySQL, basically we're a relational database. Mark required fields, mark required columns with not null, otherwise null values are allowed. In MongoDB, all fields are optional in the database. All fields are optional. That's not the case with relational databases. Required fields must be checked in the application using the server-side validation such as JOI. So yeah, that's JOII. We'll be using that for validation as well in this course. So yeah, you check for required stuff in your code, as opposed to in a database, you kind of have to set up your database. Required fields are kind of designated within your database structure itself. Okay, primary keys. Primary key can be either auto incremented. So the way it works in a relational database, you can have the very first record is going to be record number 1. Second record's record 2, right? So you don't necessarily have to know which record. It has auto increment. So when a new record's entered, it's going to take the last record number and just add 1 to it. It's auto increment. And there's also the idea of composite keys. You basically have to kind of merging keys together. I don't want to get into that too much, but that's how primary keys can be. For MongoDB database, primary key must have the name ID. So this is your primary key, right? This is your main key of your document. So it's going to be underscore ID and maybe a unique string or an object ID. And we'll look into that in the future, okay? You can create your own, or you can let it create one for you, okay? And we'll look at that in the future. Now, foreign keys and relationships. In a relational database, add a column to store a primary key of another table. So when let's say you have a product, and then you have an item. Let's say you have a product table and you have an item table. So that the item table gets all the information from the product for the product table. The way it's going to do that is it's going to be using the primary ID in your product table is going to be the foreign key in your item table. Okay, that probably wasn't the best example, but so that's how that works. Add a foreign key constraint to prevent columns from becoming invalid. In a MongoDB, you add field to document, object to store primary keys of another document. So basically, you do that all within your one document can access the other document, the other collection, right? You can actually do that. We'll look at that. So MongoDB provides no way to enforce the validity of a foreign key, and it's saying this is a good thing. All right. Unique constraints. MySQL, unique constraints are declared as part of the table schema. All rows in a table must satisfy the constraints at all times. For MongoDB, you can add unique indexes to a collection. They can include a group of one or more fields, which can be unique for each document in the collection. All documents in a collection must satisfy the constraints at all times. All right. Then indexes. Indexes are added to tables. And the purpose of indexes are to speed up things. So they speed up select queries where the columns in question are references in a where clause or a join clause. And obviously, small little database ain't going to make a difference, but you've got a substantial database, you know, hundreds of thousands to millions of customers or whatever, rows and columns, then having indexes is going to really speed that up. In MongoDB, indexes are added to a collection. They speed up the find operations. We'll be using the find method operations and filter sort data based on the index fields. They are vital to the application performance. All right. So that's all I have for this DB intro, MongoDB intro. Let's go ahead and look at, I want to just do some, I want to do some, just, some basic queries here for that, that one collection, the restaurants one. Let me grab that. So this was from before. We had this up and running. So to get rid of this, you can just hit Control C, because you're actually kind of like still you're still connected, and it'll stay connected for a long time. So show DBs, so it's it's still connected. So here, if you want to get rid of it, just Control C and press Control C again, and now you're back to your command prompt, right? So here, I'm just going to close this and start over. Not necessary, not really necessary, but just going to anyhow. And then here, just real quick, back to this. Click Connect. Go to the shell. Copy this. All right. And then here, then go ahead and right-click, enter, hit the enter key. It's going to ask you to enter your password. And then remember, this is the database one, right? Not the one that you created registering. You got two different ones, two different usernames and passwords. One of them was the MongoDB one that also Atlas uses. So enter the password, hit enter, and we're in. Okay, so I want to show you some commands here on this. Let me see here. So kind of the first thing you have to do is, sometimes you're going to have multiple databases, right? You're going to have multiple ones. So here, you want to show databases, show DBs. So here we got the mflix one. The mflix one's the one you're going to do for your assignment this week. I believe that's correct. I need to check. The sample mflix ones, and then we went ahead and added the restaurant ones. Okay. So what we're going to want to do here is use sample restaurants. So now we're going to use that database. You have to select which one to use. Okay. You have to select which one to use. So now we switch to that, okay? And then within a database is going to have one or more collections, okay? Obviously, if you created a brand new database, it's possible you have none, but once you have any data, you're going to have collections. So we're going to here show collections, okay? So the first one was show databases. We did a show databases. Then we did use sample restaurants, okay? So now we're saying use this database, and now we're showing the collections of the sample restaurants. So we got neighborhoods and restaurants here, okay? Now here is so one thing you have to do is, once you have a database, once you want to run some queries on the database that you currently have, you got to start with DB. It doesn't matter what database, right? You're still going to have to do that, okay? So here we're going to do database dot, no, that's not going to work like I wanted to, is it? No, that's okay. What I'm going to do here is First thing is you could use like what's called find. Okay, so DB restaurants and find. So here you're just saying the current database, right? It's going to be whatever database that you have and use, which, okay. And then you have different collections. One of them is neighborhoods and one of them is restaurants. And you're going to say on your restaurants collection, I want to do a find. And so this is basically going to return all records within that, okay? So it's just returning all records. Don't have to worry about all of this, but as you can see, you've got some different IDs. We're talking about different documents, right? Each one of these is a different document. All right. You got an ID, address, borough, cuisine, grades, various data, right? This is some old stuff, obviously. And, don't worry about that right now. I'm just kind of showing you just some basic commands here, and that's all. Another thing you can do is you can do a find, but let's just say I don't want, this just actually ran through all of them, however many, that was, all of them, right? So let's just say we want to, we can do .find, .limit, just like this, and we can do, say, 5 of them. That's my fault there. Okay. And so that just got 5. Let's just change that actually to 1. And you can use the up arrow key to go back to your last command, right? And so this time that just showed 1, right? Here's where I typed in just 1. So here's just 1, all right? So you can use that limit, right? Find and then .limit. Well, if you really want, but the real way, probably the best way to do the find 1 is just like this, find 1, open and close. Okay. Now you can, I'm just going to cut and paste this from somewhere. So based on this data, so here you got borough of Brooklyn, you have these different boroughs. Maybe you want to bring back so many that match, okay, that matched one of your properties, right? So in this case, I'm going to do a borough of Manhattan, and so I'm going to limit this to 5. And then obviously, if I just wanted to limit that to 1, since we can't even tell how many came back, that time it just limited it to 1, right? It's just going to bring back the first one, right? Because sometimes maybe in some certain stamps you want to just bring back the first 5 for whatever reason, right? Obviously, you can do other things that you're bringing them back in a certain order, right? And then there's more complex stuff where you're wanting to drill down the different things, borough of Manhattan, scores and grades and all of that, right? Maybe within a zip code, right? So that one was borough. And so here, let's do, and then one has cuisine as well, cuisine American. So here's a cuisine of American, and we're just limiting it by 5. And this is how you, I really didn't point out. So when you're using these different properties and stuff, you're going to be using the curly braces. So your find method is going to be an open and parentheses, but within there you're going to have a curly brace, a curly end brace, right? And then that's where you define your property. So like in this case, it's going to be cuisine, American, right? And that didn't, I know, I was just wondering, I was just kind of looking at that because we have a space in here. So you got to watch, it's always very important, right? So there you go. That brought back those. So that's how you do that one. And then sometimes, you can check, you can query, do finds based on multiple properties. And so like in this case, I'm doing a find based on the borough being Brooklyn and the cuisine being Italian, and limit that to 5. Okay, same thing there. Find a restaurant with a score greater than 90. So here's a way, and we're going to go through these some more. So here's one here. So we're doing DB restaurants find, open and close on our curly braces, and we got a grade score. And this is how you can do greater than $GT colon 90. So you're wanting all your scores that have a score greater than 90, and you're limiting that to 5 again. Just limit that to 1, just to make it easier. So where's our grade? What was our thing? Was it a score? Yeah, it was score. So yeah, well, just have one score. So you have multiple scores in here. So if it just found one that had a score, I question how accurate some of this data is here, but that's okay. All right. What else? Okay, yeah, this is kind of an interesting one. So here, let's see if this works. I'm kind of concerned that this working here. It did. So here it's basically saying, let's see, avenue. So basically it's saying, and it's doing ignore case here. So this is kind of like a regular expression where you're saying where the street address has an avenue in it. So you do a forward slash, your name there, and a forward slash, an I for ignore case, right? For ignore case in case it was lowercase a. So if the street contains avenue, right? If it contains avenue, then it's going to return it, right? Specific zip code. Yeah, I don't see that being anything exciting. We'll go through some more stuff. I don't want to. I just wanted to kind of, the biggest thing I just wanted to kind of show you is basically some of these basic functions, the very simplest ones, and we'll go through more tomorrow. But basically, show databases is going to show you what databases you have. I think if I put DB, so if you just put DB, right, it'll show you what's your current DB, what database you're using, where it's actually all there here as well, right? But it knows that which database are you logged into. So you're logged into the sample restaurant database. Show database is going to show you all of them. Let's see what I did here. Show collections is going to show you all the collections of that. Okay. So we just did restaurants. There's also neighborhoods that are another one as well. Okay. Then you need to make sure that you use the used and then put the database name, right? Same thing with the collection as well, right? Same thing with the collection as well. No, I'm sorry. I kind of misspoke there. So use collection. Use is for some old stuff there. So use is for the database for the collection that you just basically you basically state that right here, right? So you're saying my current database, give me the restaurants collection, and do a find on that. So that's all I have for today. Tomorrow we're going to go into much more detail on some of the commands and how to do what you need to do for the lab assignment. So thank you very much and have a good day.